So, for example, let's say you want to find the inverse Laplace transform of 1 over s squared plus 2s plus 5. Okay, so if you think about this, what we normally would do is we try to factor that, right? And then use partial fractions, etc., etc. But this does not factor, at least not easily, right? Most anything factors, but not easily. So we're going to fall back on if it doesn't factor, the next best thing typically is completing the square. And that's what we'll do here. So if you complete the square, you'll have this. You have 1 over, this becomes s plus 1 squared plus 4, right? Right, s squared plus 2s, you would have to add 1, right? And subtract 1, so that's where the plus 4 comes in. However you learn how to do it. I mean, you don't have to complete square, so I'm not going to go over that very much. This is what you have, right? Well, if you think about this, again, ignore the plus 1 part. You're looking at 1 over s squared plus 4. Well, that's almost sine, right? So what you need to do, of course, is you need a 2 up here, right? So you're going to multiply by 2. Which, of course, means you need 1/2 out front, right? So what you would have here is you would have 1/2 sine of 2t, right? Again, forget about that translation. You have 2 over s squared plus 4 is sine of 2t, right? And then 1/2 to count as 2. Well, if you have an s plus 1, that means the a was negative 1, right? So you should have this times e to the negative t. Remember, it's s minus a, right? So s minus a negative 1, and that's it. Okay? So in a case like this, factor, if you can. If you can't factor, complete the square, and then when you complete the square, you're going to end up with the inverse translation there. Okay? So that makes sense.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.